Hey there. Today we're going to be talking about calculating current, voltage and resistance in series and parallel circuits. So let's take a look at a series circuit to begin with. So we can clearly identify that this is a series circuit as there is simply one electric line flowing through this entire circuit with no breaks in between. This is our example light bulb and this is our example power supply. Let's ignore this switch for the moment. Let's assign some values to this circuit. Let's have the total voltage for this circuit as 10 volts. Let's have the resistance for this light bulb as 2 ohms. And let's have the total resistance of this circuit as 4 amps. So let's start by identifying the current of a series circuit. So when we find the current of a series circuit, it's relatively simple. The current in a series circuit remains constant. That means the current will never change regardless of how many appliances we add. For example, if we add another light bulb here with a resistance of 2 ohms, the total current will remain 4 amps. Therefore, the total current of this practice circuit will be 4 amps. We will also be looking at harder examples. Now let's take a look at the voltage. Now the overall voltage of this current here, of this circuit is 10 volts as it's indicated here. However, if this was not indicated, for example, you would simply use the formula R is equal to V over I, replacing I with your total current and R with the total resistance. This leads us on how to find the total resistance of this circuit. Now let's assume that we have 2 light bulbs here, both with 2 ohms of resistance. So to find the total resistance of this series circuit, what we do is simply add these two resistances. And what we would get is 4 ohms. This, in turn, would be the total resistance of our current here and would not change. So let's take a look at a parallel circuit now. So there's a clear distinction between a series and a parallel circuit, as we can see that there is a break here and here. These breaks indicate that the circuit is indeed parallel. So let's assume that we have a current of 5 amps here and a resistance of 2 and 2 ohms. We will take this time to find the voltage of this power source to give you a better understanding of how this works. So the current in a parallel circuit is actually different to what we just learned in the series circuit. Now in the current of a parallel circuit, as I can see, I've already shown you what the total current is, and it would simply be 5 amps. However, when the current travels through, it would split right at this breakpoint, as I was evidented, and become 2.5 and 2.5. This would then reconnect here and become 5 again. Now, there are questions where you are asked to find the total current, and you would do that by using the formula R is equal to V over I, and finding the current at this point, and simply adding them together over here. Now, when we find the voltage of this parallel circuit, first let's use our total current and our resistance. So before we can find the voltage here, we need to understand how do we find the resistance. So the resistance is also different to how series circuits function. To find the total resistance of this circuit, instead of simply adding 2 and 2 together like we did for the series circuit, we add 1 over 2 plus 1 over 2, giving us a decent answer of 1. Now to find the total voltage, we would simply get 1 is equal to V over 5, therefore V is equal to 5. So we can simply say that the power supply is 5 volts. So now let's take a look at some harder examples. Now you can probably tell that this here is indeed a series circuit. So let's take a crack at finding three distinct things. Let's find the total resistance, two, the total voltage, and three, let's also find the total current. So to find the total resistance, it's very easy. All we need to do is simply add these resistances together, which gives us 100 ohms, which would be our total resistance. Now the total voltage, as we know, is given to us here, so that would just be simply 125 volts. Now the total current is easy to work out using our formula again. R is equal to V over I. So we would rearrange the formula, of course, giving us I is equal to V over R. And we would substitute the values here that we have, which would give us I is equal to 125 over 100, giving us a total current of 1.25. Now, if we wanted to find the current, so as we know already, the current here would still be 1.25, because as we learned earlier, the current in a series circuit remains constant and will always remain constant. However, if we wanted to find the potential difference slash voltage at this point or at this resistor, you would simply use this formula again, except sub in this value and this value, and you would find the V very easily. So let's jump into the next example. Now, what we already know here is that this indeed is a parallel circuit. So let me write that out. So let's find the same three things, as there is a variation between these two. One, we will find the total resistance. Two, we will find the total voltage. And three, we will find the total current. Okay, so let's find the total resistance. So we've got three values here, 20, 100, and 50. So to find the total resistance, what we do is put 1 over 20 plus 1 over 100 plus 1 over 50. And what that value gives us is, one moment, let me grab my calculator. Bear with me here, sorry. Okay, so we take out our calculator. If you can do it in your head, that's even better. And we get 1. So the answer we get from this is 0.08 as our total resistance. Now that we have the total resistance, let's move on to total voltage, which is already given, 125. So we can just write that here. Now, if we were finding the voltage of this point here, for example, since this is a parallel circuit, we know that it'll also be 125 volts here, 125 volts here, and 125 volts here, because a parallel circuit keeps the same voltage across appliances. So now that we have our total voltage and our total resistance, we can find the total current. So to find the total current, we simply use our formula. R is equal to V over I. So now we substitute our values. 0.08 is equal to 125 over I. Therefore, I is equal to, let me put those values into my calculator. A very high answer of 1562.5 amps. So that's how we find these three for both a parallel and a circuit, a parallel and a series circuit. Thank you for watching. I hope you've learned something.